All right, good job hanging out with me for the first video. So let's take a look at our second video. Again, I don't think I'm going to get through everything, so we'll probably have to go into a third video. That's why there's only one lesson for our next class, because it's pretty detailed. So we already finished example 2. Let's take a look at example 2.1. Not quite example 3, it still goes along with the idea of example 2 of evaluating, but here's how we're going to do it with the calculator. Again, as I told you repeatedly before, you must have a calculator to use in class. These questions right here can be solved by hand, but it is a long, arduous, painful process. And we are no longer in the 1700s, 1800s where we have to do these things by hand. We are lucky that we are in the 21st century and we have graphing calculators, so we're not going to waste valuable time of doing this by hand. We are actually going to use our calculator. As I told you before, look at your Casio right now or Texas Instruments, whatever calculator you're using. It does need to be a graphing calculator or a pretty highly advanced scientific calculator. One of my calculators that I use in class that you sometimes see me use, the little slightly blue one, it only has the log function. It doesn't have the natural log function. I have to use the graphing calculator anytime I want to solve with the natural number e or the natural log functions. So go ahead and use your graphing calculators because it has these functions available for you. So as I told you in the first video, if you see a log but no base here, remember that means it's a base 10. And so in order to use your calculator, you have to solve it with the base 10. So if you have this function already, log of 85/100ths, type that into your calculator. So log, then my calculator does a parentheses, so I have to type in the number, and then close the parentheses, and then hit enter. The Casio's, I'm not sure, so I don't think you have to type in the parentheses. If it automatically opens, then close it, but play around with it, you'll get the correct answer. So you'll get a long decimal. Of course, these are all going to be crazy long decimals. So let's say, for example, something along the lines of this, negative 0.07058, ... All right? Unless the instructions tell you otherwise, go ahead and round to 3 decimal places. So we have 1, 2, 3 decimal places. This one tells me to round up. So my answer would be negative 71 thousandths. Okay? The natural log, again, the natural log means the base is e. So our exponent, the base is 2.71 approximately. So 2.71 to the what equals 22. Well, since 2.71 is an approximation, e is an irrational number, like pi, we want to go ahead and use the calculator for it to do the hard work for us, and then we'll round our answer. So type in natural log. You'll notice that you've been using that button to get to the e to the x. So now you're just going to hit the natural log. You don't have to hit shift or anything like that. So then, again, 22, close parentheses. That's how my calculator does it. I'm not sure how yours would. And then take a look at the number and round to 3 decimal places. Your instructions usually say 3 decimal places. If it's a word problem that I want you to put in more realistic terms, then it might be the nearest whole number, it might be the nearest 2 decimal places. It's just going to depend on the situation. Okay, so now the question becomes, what happens if you want to use your calculator because the problem you're given isn't an easy problem to use without the calculator? Let's say you have an example, log base 3 of 30 is what, right? If I tell you to evaluate this expression, well, you're thinking to yourself, okay, 3 to the what equals 30. Well, we already know that 3 to the third is 27, and 3 to the fourth is 81. So our exponent is somewhere between 3 and 4, but how are we going to know exactly what it is? Well, here's how you do it on the calculator. Now, there is a detailed reason why, and we will get into that once we start learning more about the properties of logarithms, but for now, just go with it. Here's your base b, okay? we've been calling this y, but some resources call it a. So if you take the log of 30 and divide it by the log of 3, that will give you your answer. So in this case, the log of 30, close parentheses, divided by the log of 3, close parentheses, is equal to 3.0959 dot, dot, dot. All right, so we're going to round to 3 decimal places. So this is worth approximately 3.096. Now that makes sense. 3 to the 3rd power is 27, and 3 to the 4th power is 81. Well, 30 is pretty close to 27, so our exponent, of course, is going to be much closer to 3 than it would be to 4. So again, you can use a little bit of reasonableness to make sure your answer is correct, and then go from there. But if you take the log of the answer, this is technically speaking the answer to the solution, and divide it by the log of the base, all right, that's going to use the base 10 system on our calculators, but to still help us solve out the problem. So for your notes, you may want to write that the log of y, not x, the log of y divided by the log of b. All right, that's how you use your calculator to solve logarithmic problems that are not base 10 problems. Okay, now let's take a look at our next example. This is a word problem. This is kind of a real life scenario that we would use our logarithmics for. It says the sales of a certain video game can be modeled by y equals 20 times the natural log of x minus 1 plus 35. So here's this equation. All right, or y is the monthly number in thousands of games sold. In the xth month, so the xth month, x stands for the number of months after the game is released, where x is greater than 1. Estimate the number of video games sold during the 10th month after the game is released. All right, well, 10th month, x month, so x is equal to 10. So plug that in. So y is going to be equal to 20 times the natural log, I'm going to put a multiplication symbol there to make it easier for me, of 10 minus 1 plus 35. Now make sure you follow your order of operations correctly. 10 minus 1 is 9, so we're going to find the natural log of 9 first, then multiply it by 20, and then add 35. So on our calculator, we go through that process. Natural log, 9 equals times 20 equals plus 35, and we get something approximately 78.9, but we're talking about in the thousands, so let's go ahead and round that up to 79, because that would mean 79,000 games were sold in the 10th month after the game was released. So again, putting it in kind of real life terms, if you wanted to keep it at 78.9, that'd be fine. You just would need to remember that means thousands, so you'd have to have an answer of 78,900. But again, we're estimating some nice round numbers, pretty easy. So I would have said 79,000. All right, go ahead and erase that. And let's take a look at some examples. Now these exercises really are just from examples 1 and 2. And so these are fairly simple. A lot of just that mental math of rewriting the problem and trying to figure out mentally why does this relationship work. So 1 through 4 should take very little time. 5 through 8, you kind of want to think through the process. Most of these answers are going to be whole numbers or easy fractions. They're not going to be the crazy decimals. Go ahead and press pause to take as long as you need, and when you're ready, move on. Okay, so here are the answers to the practice problems. Take a moment to check your answers. This will actually be the conclusion of this video. We'll move on to the part 3 in just a moment. So go ahead and stop once you've checked your answers.